Welcome to day one of our 15-day beginner data science sprint. Today, we are going to understand what data science really is. We will not begin with a complicated algorithm. We will begin by understanding the complete journey of a data science project. Over the next 15 days, we will spend approximately 30 minutes every day learning one important part of data science. Our core tools will be Google Colab, Python, NumPy, Pandas, Seaborn, and scikit-learn. By the end of this sprint, you should understand the complete data science workflow and be able to build your first machine learning project using Python. But before learning the tools, we must understand the purpose behind them. Imagine that you open a food delivery application and place an order. Within a few seconds, the application tells you that your food will arrive in 28 minutes. How did it calculate 28 minutes? The application may consider the distance between the restaurant and your location. It may consider how much time the restaurant normally takes to prepare an order. It may consider current traffic, weather, the availability of delivery partners, and even previous deliveries from that restaurant. Now think about a streaming platform. You finish watching one video or one movie, and the platform immediately recommends something else. How does it decide what to recommend? It may use your previous viewing history, the content watched by people with similar interests, the language you prefer, the categories you normally select, and how long you watched previous content. These applications collect data, find useful patterns, and use those patterns to support a decision. That is the kind of journey we are beginning to study. However, simply collecting a large amount of data does not automatically make an application intelligent. Data must be connected to a meaningful question. For a food delivery application, the question could be how long will this order take to reach the customer? For a streaming platform, the question could be which piece of content is this person most likely to enjoy next? The question determines what data we need and what analysis we perform and how we evaluate our result. So, the question determines what data we need, what analysis we perform, and how we evaluate our result. By the end of today's lesson, you will understand the major stages of a data science project. You will also open your first Google Colab notebook, load a small data set, inspect its rows and columns, and calculate one simple average. The goal is not to memorize Python functions today. The goal is to see the complete journey from data to interpretation. Now, what is data? Let us begin with the word data. Data is recorded evidence. A student's attendance percentage is data. The number of hours a student studied is data. A customer's order time is data. The temperature recorded at a particular location is data. A photograph, an audio recording, a written review, a transaction, and a sensor reading can all be forms of data. But data is not automatically useful knowledge. Suppose I tell you that a student scored 78. That number alone is data, but it immediately raises several questions. Was the score out of 100? Was this score considered good? Was the examination difficult? How did the rest of the class perform? Without context, even a correct number can be misunderstood. You will often hear four terms used together: data analysis, data science, machine learning, and artificial intelligence. They are related, but they do not mean exactly the same thing. Data analysis usually focuses on understanding data that already exists. For example, we may ask what was the average score of the students? Which month had the highest sales? How many customers stopped using our application? Data analysis helps us describe and understand what happened. Data science is a broader process. It includes asking useful questions, collecting data, cleaning it, exploring it, sometimes building models, evaluating the results, and communicating what we discovered. Machine learning is one technique that may be used inside a data science project. A machine learning system learns patterns from examples. For example, we may provide previous delivery information to a system and ask it to learn how different factors affect delivery time. Artificial intelligence is an even broader term. It includes systems designed to perform tasks that appear to require intelligence, such as understanding language, recognizing images, generating text, planning actions, or making recommendations. Here is a simple way to remember the difference. Data analysis helps us understand what happened. Data science help us use data to answer questions and support decisions. Machine learning helps a system learn patterns from data. Artificial intelligence is the larger goal of creating systems that perform intelligent looking tasks. One of the most common mistakes beginners make is thinking that data science means only training machine learning models. Model training is only one possible stage. In many real projects, a large amount of effort is spent before and after a model training. We must understand the problem. We must find appropriate data. We must check whether the data is reliable. We must correct missing or inconsistent values. We must explore the data. We must evaluate whether the result is actually useful. Finally, we must communicate the result to someone who may not know Python or machine learning. A highly accurate model is not valuable if it answers the wrong question. A simplified data science workflow contains seven major stages. The first stage is ask. We define the question or problem. The second stage is collect. We gather the data required to investigate that question. The third stage is clean. We correct errors, handle missing values, remove duplicates, and make the data consistent. The fourth stage is explore. We calculate summaries, create visualizations, and look for patterns. The fifth stage is model. When necessary, we build a statistical or machine learning model. The sixth stage is evaluate. We check whether our analysis or model is accurate, reliable, fair, and useful. And the seventh stage is communicate. We explain the result, its meaning, and its limitations. The workflow is not always a straight line. While exploring the data, we may discover that important information is missing. We may then return to the collection stage. While evaluating a model, we may discover that our original question was too broad. We may return to our first stage and redefine the problem. That is why data science is an iterative process. Now that we have seen the complete workflow, let us perform a very simple version of it. We will use a student performance dataset. Our question will be, what is the average final score of the students in the dataset? What is the average final score of the students in this dataset? This is a simple question, but it will allow us to explain several stages of the workflow. So let's open colab.research.google.com. Open your browser and visit Google Colab. Google Colab allows us to write and run Python code directly inside the browser. You do not need to install Python on your computer for this lesson. You will need to sign in using a Google account so that your notebook can be saved. Now click New Notebook. I have already opened the new notebook, but you can open it from here. This page is called a notebook. A notebook is divided into cells. A code cell contains instructions that Python can execute. A text cell can contain headings, explanations, links, or notes. The play button on the left side of a code cell runs that cell. You can also run a cell by pressing Shift and Enter. The output of the code normally appears directly below the cell. This makes Notebook useful for data science because we can keep our code, results, explanations, and visualizations together. So before writing any code, let us rename the notebook. So I am renaming mine to day underscore 01 underscore what underscore data underscore science underscore really underscore is. The file extension .ipynb stands for IPython notebook. Google Colab saves the notebook automatically in Google Drive. However, you should still check the saving status before closing it. Let us create a text cell. So to exit, to save the text cell, we press Shift and Enter. To run the code also, we press Shift and Enter. So I added a text cell at the top of the notebook. Let me delete this cell. The heading tells us that what this notebook is about. I am also writing the question we are trying to answer. This is an important habit. A data science notebook should not begin with random code. It should clearly state the problem being investigated. So always keep heading of the notebook with the problem being investigated at the top. Our data is stored in a CSV file named studentperformance.csv. I have already uploaded the database, the CSV file. CSV stands for comma separated values. Each row represents one student. Each column represents one recorded characteristic. For example, final score contains the final score of each student. Study hours contains the number of hours studied. Attendance percent contains the student's attendance percentage. So to upload the file, we click on this file section and click on this files from here and then click on upload. And from there we can upload the file. Colab may tell you that the uploaded files are temporary. That means the file can disappear when the Colab runtime is restarted or disconnected. Your notebook is saved in Google Drive, but a file uploaded into the temporary runtime may need to be uploaded again in a future session. So you should verify the file after uploading it. Like I have opened it by clicking it, and you can see on the right side the complete file details. Before continuing, always verify that the file name is correct. Even a small difference in spelling, capitalization, or file extension can cause an error later. Now let's create a code cell and write this code import pandas as PD. We are using a Python library called Pandas. A library is a collection of code created to help us perform common tasks. Pandas is widely used for working with structured data, especially data arranged in rows and columns. We write import pandas as PD. The word import tells Python that we want to use the pandas library. The part as PD gives pandas a short name. Before I run this cell, what do you expect to see? Will it display the current complete dataset? Will it print a message? Or will it simply prepare pandas for use? The cell has completed, but no visible output has appeared. That is expected. This instruction imports pandas. It does not ask Python to display anything. No visible output does not mean that nothing happened. Let's create a new code cell and we will upload the CSV file. We write df equals pd dot read underscore CSV followed by the file name inside quotation marks. The function read CSV reads data from a CSV file. We are storing the result inside a variable named df. The letters df commonly stands for data frame. A data frame is a pandas object used to represent data in rows and columns. Before I run this cell, predict the result. Do you expect the complete data set to appear automatically? Once again, no dataset has appeared. The data has been loaded and stored in DF, but we have not yet asked Colab to display it. This cell performs an operation. It does not automatically communicate the result. Now I will create a new cell. Let us inspect the shape and dataset. Shape of the dataset. The shape tells us how many rows and columns are present. Before running the cell, look at the dataset and make a prediction. How many students do you think are included? How many columns have been recorded? The output is 10, 5 inside parentheses. The first number represents the number of rows. The second number represents the number of columns. Therefore, our dataset contains 10 rows and 5 columns. Because each row represents one student, we currently have information about 10 students. However, this output does not tell us whether the information is accurate. It does not tell us whether any values are missing. It does not tell us whether these 10 students represent a larger population. Shape tells us the size of the dataset, not its quality. Let's create a new cell and write this code. We will look at the first few rows. The head function returns the first 5 rows by default. We will use display so that Colab shows the result as a formatted table. Before running the cell, what do you expect to see? Will it show all 10 students or only a smaller sample? We can now see the first 5 rows. Each row represents a student. The student ID column provides an identifier. Study hours records the number of hours studied. Attendance percent records attendance. Previous score contains an earlier score. Final score contains the final score. Looking at the first few rows helps us understand the structure of the data. It also helps us notice obvious problems such as an unexpected column name or values appearing in the wrong place. But these 5 rows do not prove that the remaining rows are correct. A preview is useful, but it is not a complete data quality check. Notice where we are in the data science workflow. The CSV file represents the collection stage. Checking the shape and viewing the first rows are early parts of cleaning and exploration. We have not built a model. We are first trying to understand what data we actually have. Now we will answer our original question. What is the average final score of the students? Inside DF, we select the final score column. We then use the mean function. The mean is calculated by adding all the values and dividing the result by the number of values. The print function displays the level followed by the calculated average. Before I run the cell, make a prediction. Based on the scores visible in the table, do you expect the average to be below 50, around 70 or 80, or above 90? You can see the table here. So run the cell and expected output is average final score 78.0. The average final score is 78. Now comes one of the most important parts of data science, that is interpretation. A technical statement would be the arithmetic mean of the final score column is 78. The statement is correct, but we should also be able to explain it without technical jargon. A simpler interpretation is the 10 students scored 78 out of 100 on average. That is the sentence I would use when communicating the result to someone who does not use Pandas or Python. However, we must be careful. The average does not mean that every student scored 78. Some students scored more than 78 and some scored less. The average also does not prove that studying more hours caused higher scores. It does not prove that attendance caused better performance. At this point, we have calculated a summary. We have not established cause and effect. We have calculated a summary. We have not established cause and effect. This distinction is extremely important. Data can show an association or pattern, but a pattern does not automatically prove causation. Suppose students who study more hours also have higher scores. Can we immediately conclude that increasing study hours will improve every student's result? Not necessarily. Students who study more may also have better learning resources, stronger previous knowledge, better health, or fewer outside responsibilities. These may be factors that are not recorded in the dataset. Responsible data science includes explaining what the output does not prove. Before continuing, pause the video and explain the most important output in one sentence. Do not use the words data frame or pandas, mean function, column selection, or arithmetic operation. Imagine that you are explaining the result to a school teacher or a parent. Your sentence should communicate the meaning of the output, not the code used to produce it. Pause the video now and write your sentence. One possible sentence is the students in this dataset scored 78 out of 100 on average. Your wording may be different, but it should be understandable without technical knowledge. Now complete the main day one challenge. Write one question that this dataset could help us answer. Then write one question that this dataset cannot answer. A question the dataset can answer must be connected to the columns we actually have. A question that dataset cannot answer may require information that was never collected. So add a new text cell to your notebook. Write the three headings shown on the screen. Do not begin by searching for complicated code. First, identify the information available in the dataset, then compare it with the information required by your question. Pause the video and complete the three statements. Remember the solution direction. First, identify the input. The input is the information available in the dataset. Second, identify the operation. The operation could be comparing, counting, averaging, or finding a relationship. Third, describe the expected output. Do not worry about writing the Python code for your new question today. The purpose of this challenge is to practice asking questions that match the available data. So first we identify the input, second identify the operation, third describe the expected output. One possible question this dataset can help us investigate is higher attendance associated with a higher final score in this dataset? Let me type that out. We have attendance percent and final score. So the necessary inputs are available. Notice that I use the phrase associated with. I did not say that attendance definitely causes higher scores. Investigating causation would require a stronger study, design, and possibly more information. The second question can be that dataset cannot answer is, does getting 8 hours of sleep improve the student's final score? The dataset does not contain sleep duration. Therefore, we cannot answer that question using this file. Python cannot create evidence that was never collected. A sophisticated algorithm cannot compensate for missing information that is essential to the question. My one sentence interpretation is, The 10 students scored 78 out of 100 on average. This is short, clear, and directly connected to the output. Let us connect this small demonstration to the complete workflow. We started by asking a question. What is the average final score? We collected or received a CSV file. We inspected its shape and first rows as an early cleaning and validation step. We explored the final score column by calculating an average. We will evaluated the meaning and limitation of the output. Finally, we communicated the result in one simple sentence. We did not need a machine learning model. That does not make this activity less valuable. Data science is about answering questions responsibly, not using the most complicated algorithm available. Let us recap day one. Data is recorded evidence, but data is not automatically useful knowledge. A data science project begins with a meaningful question, not with an algorithm. The major stages are ask, collect, clean, explore, model, evaluate, and communicate. The process is iterative, so we may move backwards and forwards between these stages. Analysis, data science, machine learning, and artificial intelligence are related, but they are not identical. Today, we also opened a Google Colab notebook, imported Pandas, loaded a CSV file, inspected its shape, displayed its first rows, and calculated an average. Most importantly, we interpreted the result and discussed what it does not prove. Before leaving, confirm that your notebook is named day 01 what data science really is. .ipynb. Check that the notebook has been saved to Google Drive. Your notebook should include the code, the outputs, your two questions, and your one sentence interpretation. On day one, we gained the ability to look at a dataset and connect it to the larger data science workflow. You should now be able to explain what the shape output means, what the average score means, and what that average does not prove. In the next lesson, we will understand datasets more deeply, including rows, columns, features, observations, and different types of data. Complete your notebook, save it, and I will see you in day 2.